Okay, let's take a look at question 14 in sample exam 3 in Chem 11. This question is a thermochemistry question that is asking you to compare the value of delta H and delta E, enthalpy change versus energy change. And you have to assess whether the enthalpy would be greater, less, or equal to the energy change. In order to answer these questions, you have to remember the relationship between enthalpy and energy. And that starts from this equation right here, where delta E we know is equal to Q plus W. And then under constant pressure, that heat we call Q sub P, or heat under constant pressure, which we can also call enthalpy change. So in other words, your delta H is equal to delta E minus W, but recall that in chemistry, the work that we care about the most is something called expansion work, and that expansion work has the following expression, negative P external delta V. So you can see that delta H is equal to delta E plus P external times delta V. Now, of course, this component here will determine whether your delta H is going to be equal, less, or greater than delta E. And so the question is, what would affect the value of P external times delta V? So remember that expansion work occurs when you have a change in volume. So you can have your reaction container becoming bigger than what you started with, so that's expansion, or it could become smaller than what you started with, so really, really tiny here. That's when you have fewer gas, right? So this is compression. So you notice that you have expansion when you have more gas in final state or in product versus reactant, and then you have compression when you have fewer gas versus reactant. Another way to think about this is we can rearrange this equation that we wrote earlier, P external delta V. So we have PV equals nRT. So if we have P times delta V, then that's just equal to delta N times RT under constant temperature conditions. So in other words, our delta H could be written as delta E plus delta N RT, where delta N here represents the number of moles of the gas in the product state minus the number of moles of gas in the reactant state. And so we just have to subtract the number of moles of gas in the product from the reactant and then see if that number is positive, negative, or zero. Okay, and that's how we're going to be able to figure out what our value of delta H relative to delta E would be. So let's take a look at the reaction itself. If you look at the reaction right here, it says C3H8, so that's a gas, so that's 1 mole of gas because the coefficient is 1. 5 moles of gas, so plus 5. So your reactant has 6 moles of gas, and then your product, 3 CO2 gas, so that's 3. You have H2O, but H2O is a liquid here, so that doesn't count because liquids don't make big changes in volume, only gases do. So basically you have a 3 in the product and 6 in the reactant. So your equation would look something like this. Delta E plus, this is 3 minus 6, right? RT. And this is a negative number, negative 3 RT. So if delta H is equal to delta E minus something, that of course means that delta E is a bigger number than delta H, or delta H is a smaller number than delta E. Okay, so that means that your answer here is C.